But still, for yours, for exploring stars and galaxy formations, your main tool is light. Like, but
Yes.
why is it that important? Like, isn't it just you see a pretty color in the sky and you see, oh, that's yellow. That's pretty.
I see what you're saying. So there's a lot of really interesting physics behind that light. So, for example, hotter objects emit more light in the ultraviolet and in the blue. Colder objects emit more light in the red. You can,
Which is like what is ultraviolet and what is
oh,
red?
sorry. So like ultraviolet are very short wavelength, high energy light. It's like the light that comes from the sun that gives you skin cancer or sunburns. And then infrared light, which is very long wavelength light. So this is if you think about like the rainbow, our eyes see in a very, very narrow range of light wavelengths. We see red, orange, yellow, green, blue, purple, right? And so purple is the bluest of the light that we can see. But beyond that, there's plenty of light that's even bluer than purple, like ultraviolet light, and then even like X-rays are just a form of light that are even shorter wavelength and higher energy. So very hot things in the universe emit in the ultraviolet, and very hot things emit in X-rays. At the other end of the spectrum, if you go, purple all the way down to red is the lowest energy light that we have. And so you can actually think about this. If you imagine think about a lighter is a bad version of this, but like a blowtorch is a good version of this. If you think about what a blowtorch looks like, when the flame is coming out right near the tip where it's hottest, it's blue and purple. And then as that flame gets further and further away from the blowtorch, it's red, like orange and red. That's because it's cooling off. So as things cool off, they shift in their light from purple to red. And then it actually shifts even further into the infrared, but we can't see in the infrared with our eyes. Some animals can, but we can't. And then it can even shift further into the radio waves. So like the radio waves are literally the same things like your cell phone or radios in your car get. It's a radio. So
so this is like a cool topic, like, and it's not really straightforward, right? That there's this thing that exists, and this thing is this thing is how we see it, right? Like we get this thing, it interacts with our eyes somehow, and we get these pretty colors, but there's also this thing in other forms that can interact with you in many, many ways that you cannot really see. So we would need instruments. There. Yeah,
exactly. And it's there all the time. So, and nothing is emitting just one type of light. So here's an example. Our sun, the nearest star, the surface of it is 5,000 degrees. 5,000 degree light happens to emit most of its emission in the optical. Red, orange, yellow, green, blue, purple, which is what we see. So humans naturally have evolved over time to see primarily in the optical. The sun is also emitting other wavelengths that we don't see. It's just not emitting as much of them. It's emitting ultraviolet light. That's why you can't go outside without sunscreen, because that ultraviolet light is high energy light that burns your skin. It's also emitting infrared light. We can't see it. It also doesn't really do anything to us because it's low energy. So everything, you yourself right now, because you are a cold object relative to things, like you're like, 500 Kelvin or 300 Kelvin or something, most of the light you emit is actually infrared. And so I can't see you in the infrared. All I can see is the optical lights from these lights in this room bouncing off your skin and hitting my eye, because my eye sees in the optical. But you are actually emitting most of your own native light in the infrared, as I am. So if I shut off all the lights in this room, if I had infrared goggles on, I could see you. And that's what night vision goggles are. Night vision goggles allow us to see in the infrared, and they allow me to see cold objects like people and animals at night, even when there's no optical light to hit them and bounce into my eyes.
Right, and there's also, I've seen ultraviolet lenses that you can actually see when you put sunscreen, that it gets totally dark.
That's cool. I've never seen that.
Yeah, it's pretty cool, that's the reason, because you think of I'm just putting this cream that is just dirty and yucky that you put in your skin, doesn't do anything, right? But when you actually see an ultraviolet, you put your sunscreen and your skin looks way darker.
Oh, that's cool.
Because you're not seeing any of the ultraviolet light getting reflected. So it's pretty cool.